And so you all know, my name's Dylan. I've been the electrical system leader for the past 3 years, and I was the project manager last year. So first thing to do to use I2 is open the program, which I already have open, and then you need to open the project. So first time you start up, you'll see this screen. Um, if you've opened up projects before, you'll see the list of projects here. So the project isn't just that's the only thing you're going to use. So out in the racing industry, you'll see people with multiple projects. So projects for specific teams. As you see, I have one for a Grand Am team that I've worked with temporarily. One from for the past 2 years, my current one. And you'll have people that will have 10 projects just for specific things. Luckily for us, we only have one car to worry about, and things get a lot neater. So to open the project, you'll have to find it. So open an existing project, find out wherever you saved it, open the project file. Should have already done that. And it's useful to click on the button to on startup load previous project. That way you don't have to always click on this to open it. So this is the project. One thing all of you will notice that's different right now is I have a black background, you guys have white. That's going to be changed right now. So having a black background gives a lot better contrast with the colors of the data that's being displayed. So it's not so much a preference thing, rather you want a black background so you can see the data better. So you go to Tools, Options, um, Colors. You may also notice that Colors has a U in it. MoTeC's an Australian company, so you'll see a bunch of Australian spelling. Um, Once you're on the Colors tab, select Scheme and go to MoTeC Black. Then press OK, Apply, and it will make the change to give you the nice black background that no longer blinds you. Now, once you have that done, next thing you need to do is open a file. So to open the file, you can go over to the left where the icon says Open File. You can also press Control O, and that's a short key to bring it up. So then from there, you have to find out where you saved the file and find it. So right now, I'm going to be working off of the endurance log. That's saved under the 511 to 2013 MIS. And you'll see in the session, it says endurance full. After competition, I split up the logs to have each individual driver. That way we can compare them after if we want. So some things you'll notice when you're opening the log is there's several key information displayed on what's going on with each log. So you have your event name, venue, driver, session, date, time, and you can customize this layout by right-clicking at the top. You can select to put what information you want on there. That's something personal, a little personal preference. Like I always like to have the date and time on there because I organize my data from earliest to latest runs. But you can add, if you added vehicle ID, it's going to be the same for us because we're only running this one car. But having the driver, the comments in there, extremely useful. So a little bit about the file structure. MoTeC, when we download the logs, the default file structure for where it saves is in your C drive, MoTeC, log data, and then in here you can save different folders for each different test day, or each different session. You can it's just a folder. You can make your folder structure however you want. And in each of these, this is where your log is saved. So this is the file name for each log. The reason why there's just a bunch of numbers and you don't see the information displayed as you see here is in each log, it saves this information to display in I2, making it easier to tell what it is. But when you're looking at this individual log, the first few numbers are the date. So you can see in the log that I have highlighted right now, that's 2013, July 23rd. Okay, so that's something I saved at work. So these logs up here are what were at competition. And then the next 5 numbers are the serial number for the device that it came from. So as you can see between several of these logs, the serial number for the dash we have is 723. And one I was using at work is 15016. Then following that, it just increments your number 0, 0, 1, 2, 3, 4. It will do that. So each time you save a new log in that folder, it just increments in number. And then the rest of the information is displayed in I2. So once you found the log, open up the full endurance log, and now you'll see at the top laps displayed, and depending on what screen you were on, a whole bunch of data. So what type of data it is depends on what we're looking for. So in I2, you can have time distance graphs, outing graphs, color graphs, histograms, everything displayed here. Each has their own specific use. I'll go over a few of them and show you how we're using them. But if you have any specific need, you can create it yourself. One thing I do want to point out real quick is any change you make to in I2, it's permanent. There's no undo button. So if you delete this graph, Control Z, oh, well, they apparently fixed that. Sorry, this is a new version of I2, but sometimes deleting a channel, you can't undo. So I don't remember what channel that was. Actually, it was absolute cheese. But if you delete a channel, you have to go back and add it. So don't just start deleting everything. Now, the structure of I2. So you have your program I2, your projects, and then the next hierarchy is your workbook. Your workbook contains worksheets. So right here, over on the left side, you see a drop-down menu for 11 different workbooks, each for their own specific system with specific uses. To go between workbooks, you click on the drop-down menu and go to whichever workbook you want. You can also hold Control and press the number for the workbook, a really useful hotkey. And then your worksheets, to flip between those, you press 1, 2, 3, whatever the number may be. And your worksheets are what contain your graph and display the data. The workbooks, everything's set up by us. When you first start a project, it can be completely blank. So you can, if you ever need to add any random information, I created a random tab, but you can right-click at the top, new worksheet, and then you can add whatever data you want, and whatever graph it may be. You can also right-click, go to the layout editor, and this is how you can organize all your worksheets and workbooks, which is quite a lot. So if you're from the projects. So if you're going ahead and making a new worksheet with new data, let's go ahead and add the time distance graph. It's one of the most commonly used um, types of charts. Once you add the graph, it'll display time distance graphs properties. This is what you use to put your data in and how you organize your data in this specific graph. So this is now organized with groups and channels. So we'll go ahead and first just add 5-volt aux supply. Right now you can just select whatever channel you want. Just something to add. And then you click OK and it brings up your 5-volt aux supply. So this is the 5-volt channel that's being sent to the sensors to power them up. Now if we wanted to add another channel, let's say with a different axis, you'd add another group and go to add channel again. And I guess real quick, to bring up the time distance graph properties, you press F5, it pulls it up. And if I miss anything that you guys are confused on how to bring it up, let me know, because I know sometimes I just go out on hotkeys and you guys may get left behind. Yeah. Oh yeah, you can do that. Right click F5. Yeah, it's like or right click properties F5. I told you I'm too used to hotkeys. I'm useless without them. So F5, add channel. Forgot to add the group. Absolute G. So it created a group for me. Sometimes i2 does that because it recognizes the type of channels are too different. So it's pretty good on recognizing that you may not want to display absolute G and your 5-volt supply in the same graph, because one is 0 to, in this case, 1.7. The other one's pretty much just 5. So once you click OK to that, you have another channel. And then you can just keep on adding whatever channels you want. You can hold Control to add multiple channels, and you start creating graphs. And when you go and add a channel, all of these are what has either been recorded by the data logger or what is generated in i2 from math. So anything where you see the 0, 1, 0, 1 is a raw data value recorded by the data logger. But if you see sigma 10, that's something generated in i2. So for example, this absolute G, that was a math channel used just combining lateral G and longitudinal G. And I'll go over the math function soon. So on top of this, well, now that I have two absolute G's displaying, which is completely useless, to get rid of one, you right-click on the channel and it will delete it. So the reason I bring that up is be careful double-clicking on the channel rather, because you'll delete your channels, which can be very annoying since Control-Z doesn't work. What did I just do? I have graphs. You can also go to your properties and go and remove the channels that way if you want. So this is just your setup always. Another note about the channels is you notice that right now they're all displaying at a specific color. I have it set up so that each time you add a channel, it's like this ABS motor current one, no matter where you add it, it's going to be blue. And the reason we do that is to make sure that all of the channels you add aren't just going to be the same color. Some thought was put into it to make sure that there's different colors. So on uh, something like suspension system and wheel speeds, what we'll do with that is the front right corner is some color, let's just say green, I don't remember off the top of my head. Rear right is, say, blue. That way we know it's like all the values for that corner are a specific color, just to make it easier, and it helps with your memorization on where that channel came from, aside from the channel name. So I'm gonna go away from this and I'm gonna go to the engine workbook, and right now work on worksheet 1 called Vitals. So here, one thing I want to bring up, which is in addition to the graph property, is the use of the scale mode. Whenever you add a channel, it right away automatically scales it to whatever the channel values are. So let's just say you have a channel that was only had values between 5 to 10. When it does the automatic scale mode, you're not going to see 0. However, sometimes you do want to see that 0 value, depending on what it is and what you're looking for. Let's just say the data we had for engine temperature, if I'm going to go ahead and open up the second driver. As you can see here, I'm going to switch between the data, and on this axis, right now it's in auto scale mode. You'll see that the axis changes. So now you have 20 on the bottom because I have a higher value than I did in the other log. Sometimes you will want to display 0, other times you don't need to. It's a little bit of personal preference. One good example is this battery volt channel. So for battery voltage, we're typically seeing between 12 to 15. And some people like to have the full range, 0 to 15, and you'll probably also even increase it to 16 if you want. That way they can see relative from 0 where's the battery voltage. But in my preference, I want to look at these small spikes and see what's going on, because if I change the scale automatically, which you'd right click or you'd double click on the group and you go to mode, channel auto scale. In this case, I'll see that it goes to 8.4 to 15. Okay. All of a sudden, the scale increased and I don't get as fine resolution looking at it. I can change the size of the graph by pulling down on another one, adjacent graph above or below. But still, for me, the reason why it went so low was some dip right here, which could just be a fluke, a single point. And what I did here was the S button goes between lines and data points. So right now it's just displaying the individual data points that were recorded. So I can see that, oh, there's just one single data point that dipped low. That may just be a bad measurement. I think it may actually be from the ABS unit. But normally, I don't need to worry about that, because if I go back to that, which I want, I'll easily see right now that's like, oh, it went below what I want it to be. And over on the right side of the screen, I see the lowest value in my current view is 8.38. So that's something I'm going to catch anyways, but normally I like to get this finer resolution. And a lot of these dropouts you see, they'd normally be concerning for a car, because why is your battery voltage dropping out? Do you have a bad connection somewhere? In this case, these battery voltage dropouts are from the ABS unit. So I'll go with an example right now to show you how we figured that out. So in the electrical workbook, workbook 9, I have ABS, and I have my channel for battery voltage, some ABS motor current, and brake pressure as well, along with some other channels, but this is the simple basics. So as you can see, like battery voltage was fairly good. It's a little jumpy right here. And then apply the brakes. We zoom in, and you can zoom into any example you want. When you see this ABS current kick on, there's a small time lag. Then you see the battery voltage dip, because we're seeing, in this case right here, the total current from the ABS unit pulled 60 amps, which normally our car runs at about 20 to 30. So that ABS unit going up to 60, that's a huge increase, and that's what's causing the battery voltage to drop. Sorry. To zoom in, there's several ways to do it. On your mouse, you can scroll out, scroll in with the wheel. Another way to do it is double left click somewhere, and then this gives you the drag option to go with what data you want to view. Click again, and it goes into that highlighted data. Likewise, you can also press the up and down arrow key, and zooms in, zooms out. F2 will bring up the entire data set. W just does a single lap. So it's like if I was zoomed in, looking at something very tight and wanted to go back to that full lap, I press W, goes to the full lap. To change laps up at the top, you can click on the lap number you want. So say I want to go to 7, double click on 7, brings it there. Hotkeys to change to laps are P and N. Previous lap, next lap. A lot of the hotkeys make sense with what key it aligns to, so you just have to play around with it enough to recall what each thing is doing. So that's how I'm changing my data view. So with the ABS unit, it's causing those decreases. Before we had the ABS unit, I'd be very concerned if I saw something like that, but that's just a normal occurrence now. So when I'm looking at the battery voltage data, I'm really looking at the absolute minimum and maximum, and I can see it's like when I go to the full screen view of endurance, the lowest value was 0. And the way I'm looking at this is on the right side of the screen, you have a min, max, and average value. So right here, the blue arrow is your minimum value, red is your maximum, orange triangle or orange square thing is your average. You can bring this on and off by pressing M. Sometimes it gets annoying when it's in the way, which is why you'll want to know about that. And to find out where the value is, if you hover over the minimum value, you will be able to see a line appear on the screen. So right now it's appearing right here. In a full data view, it's sometimes hard to see. You see a blue line pop up when I hover over the number. And then you'll see a red line pop up somewhere. Yeah, at the very beginning. Another quick way to find it is if you double click on the number, it brings your cursor straight to that value. So right now it's like, why was it 0? Double clicked on it, it's occurring right here. Question? It just goes to the minimum. So in this case, 0 volts, the car is dead. They're literally turned off. So that's why I'm not concerned with the value of 0. So in the case of looking at this data, I would look at data outside of that range. and right here I see a voltage of 8, and that's a bit of a concern. So I would investigate that point more closely. Um, in this case, the driver turned the car off. That's something I found out looking at other channels. Yes?
So the numbers there on the right are what you see in the window at a moment in time.
Correct. And another thing I added, you can see this faint blue line. That's a minimum value line that I put in. If you go in and edit the group, you can display a minimum and maximum line. I put a minimum line of 12. That way, when I'm looking at the full view of data, I can quickly see voltage dropouts that go below 12, just for some quick investigation. But in the case of where it's the ABS unit causing it, that's sort of a shrug off in the shoulder. Just as long as I see the general trend of the voltage, the average voltage is staying in the range we want, somewhere between 12 to 14. Start going lower, your ECU may turn off, data logger may turn off, devices don't work at their optimal range, such such as that. So we've been working with the time distance graph a lot. You also have scatter plots such as this. So right here we see the oil pressure curve. This is something very useful in finding out, like, did we have any oil pressure dropouts? Like right here, we see like, oh, there's some point that definitely went below the minimum value we'd want. And this minimum value is decided by our system leaders. So it's like, why'd that happen? In this case, if I click on that point and click on the left arrow and right arrow, I can go between data points. So doing this, I'm going between each data point and see, like, that was just one random dropout. The dropout could have been caused by an air bubble. So that may not be the true oil pressure. So when we see just one small data point like that, it's something to keep note of, but it's not an immediate concern because an air bubble may happen. We don't know for sure, but keep an eye out on it. You'll also notice that these graphs are colored. So in the histogram properties,
So I'll just find that plot first time that
okay, yeah, it is. So
looks strange first time to see data that it displays the plot that's
yeah, so I'll go ahead and explain the oil pressure and fuel pressure plot, particularly fuel pressure because of this, for Jonathan shutting the car off. So this fuel pressure plot, the most of the data generated was with this peachish color. As you can see over on the right, the color samples, it displays 12,000 data samples at this particular engine temperature. So, and at the bottom graph, at the bottom axis, x-axis, you see engine RPM, y-axis is oil pressure. So what we can see here is as your engine RPM is increasing, you always have this general trend of your oil pressure is increasing. But then you'll notice that the oil pressure curve begins to knee off. That's due to the oil viscosity. So you end up reaching a maximum pressure that you'll be able to reach with that specific type of oil you're using. And then you also see that that also changes with your engine temperature. So most of the data was generated at somewhere between 90 and 100 degrees Celsius. And a lot of the data in here is in metric units. That's something you can change. I'll go over that real quick. Personal preference again. So I have PSI and degrees Celsius here, so I'm mixing unit systems, but it's not like PSI and KPA in the same graph confusing us. So as you can see, with a cooler engine temperature, the kneeing point comes a lot sooner, and you have a higher oil pressure at lower RPMs, as well as a little higher maximum oil pressure. So that's why sometimes when we're viewing the data, where it's like, well, this isn't the operating range of our temperature, our engine temperature. So if you go over to the color channel, you can click on the specific color and decide not to display that data. So like an engine temperature at 20, we're never going to be running with a car that cold. We always warm up the car. So any data like you see, say for example, these two data points may just be from the car warming up, except it doesn't have the intermediate value. So sometimes you exclude that warm up data since you're just sitting around doing nothing. Sometimes though, something may happen during engine warm up, so it's good to keep an eye on that. So again, depending on what you're looking at, you may not want to display everything and clutter your screen. So again, this need is due to changes in oil viscosity and the limits of the oil type we're using. Now, if you want to change what the color channel is, you right click, go to the properties, and that's going to be the same for any type of chart you have. Right click, properties, the layout's different for your histograms, your channel reports, time distance graphs. So you can add multiple channels into your y-axis. You have your x-axis, scaling, gating if you want to exclude any type of data. All this is displayed with these properties. I'm not going to take the time to go over every single bit that you can do with it, just because it would take a lot longer than an hour. And then you have your color channel to display what do I want my my data to display in color from what channel. So in this case, we're using engine temperature, and then we have a scaling, how many different bands we want. You can do it by bandwidth. So in this case, it's each 10 degrees, or you can do it by number of bands. So you could do it by, it's like 10 bands, but that may only be like not every 9 degrees. So it's whatever you want. As well as coloring, you can customize the coloring if you want. We typically just use the blend. That way it blends, as I add all these channels, it blends between red and blue, and it's clear to see what the difference is between each one. So then for this fuel pressure graph, I'm going to go ahead and click on the data points and just go through it. I actually got the right one. But you can see that the fuel pressure was dropping off. From some investigation with some of my electrical channels in switches, I ended up finding right. Oh, let me make sure I get to the right point because I was still on the full data view, so it wasn't exactly looking where I wanted. So if we go to the fuel pressure dropout, I'm gonna just find that real quick. My fuel pressure dropped out right here. I'm gonna put my cursor on that, and when I go to the other tab, the cursor will be at the same point. So it's like, why was my fuel pressure dropping out? Well, exactly where the fuel pressure began to drop, I see that the ignition state switch dropped from 1 to 0. So it went from on to off. The car shut off, so we lost fuel pressure. So that's not a system failure. That's a switch was too... We can say driver failure, but the switch may have also been too close to the shifters. So that's good to know that we didn't blow a line or there wasn't a plug. So that's
It's so long with the bigger issues, right? Like failing fuel pump,
right.
failing component. So a big part of what we have to do is to be able to get to the point where we can identify normal operating parameters for a system or component, and by monitoring it regularly, you can actually predict when a component is starting to fail.
Yep. So that's something that I do every single time the car comes in. When the car comes in, we get the logs. The first thing you always look at is your vital engine sensors, because no matter what anyone says, tuning your suspension can wait. If your car is blowing up, take care of it right now. Don't tune your suspension first. You need to know if your car is going to blow up. Bad news bears. Um, so I always end up zooming out and looking at these channels. It's something I developed to know is like what the battery voltage should be, what our fuel pressure is set to, um, coolant pressure limits, which again I have a maximum channel value, channel line, and I'm doing a lot of just looking at the minimum maximum values because engine coolant pressure. If I see any weird dropouts, I'll take note of that, but then quickly look at maximum value. Okay, it did not exceed 200 kPa or is not going anywhere close to it. We're good. Um, and then I'll just go over a few other type of channels we have. Lap reports. You can have summaries of what your what each channel was, your minimum, maximum values, and values. If you go to your properties, you'll see what you can display. So when you can, take some time just flipping through all these channels, just seeing what it has and what you're able to do and what we currently use. Another thing to note is the reason why this is called a time distance graph is you can display it in time or distance. What you're displaying it as is completely what the task is. So right now it's been displayed as time. That's the default. But if you press F9, it will change the bottom axis to distance. And if you go to data and click on time distance, that's another way. Or remember F9. So it's obvious that there's a huge difference between time and distance. If you just click between the two, you'll see some instant changes. It's like, well, what's going on at lap 13? Why is lap 13 so short? It's like, time-wise, it's a good relative time, but when I go to distance, it's hardly anything. So if I go to just lap 13 and zoom out a little bit just for a good comparison. Also, another way to scroll through data is if you hold shift and press the arrow keys, it moves your window view to the left or the right. So you're not increasing or decreasing the size of the time or number, the amount of data you're viewing, you're just shifting it. So I can see it's like, well, for some reason this was just a really short lap, but further investigation shows that it was the driver change. They pulled in just a little outside the track, and car was at idle for a little bit. You can see every single channel drop off because the car was turned off. So that's the importance of knowing whether you're working in time or distance. Because if I was looking in time, oh, it looks fairly long, but nothing was going on. So sometimes if you have a car, say, sitting in a pit, particularly professional race cars that don't use fans on the radiator, they just rely on the airspeed with how fast the car is going. When they go into the pit, in a time view, you'll see a gradual increase in engine temperature. But if you go to distance, you'll see a sudden spike because the car stops and it's sitting there for a little bit. The engine temperature is increasing, but because distance isn't changing, you don't see it change gradually. Then as soon as it moves out from the pit, you see this data point just jump up high. It's like, well, what caused that change? No engine temperature value is just going to do that in a normal time view. unless something was seriously wrong, which could be a broken sensor, or would most likely be a broken sensor if it actually did that, because it's not actually going to do that. So now I'm going to point out a few key features of what we're doing inside of I2. So, for example, you can see on this page, there's a channel called overrev, and it says NA. Overrev is a math channel I created to calculate whenever the driver has exceeded the maximum RPM we want. That way we can keep track of how often the car overrevs and what value, which for us would happen due to a downshift because the ECU will limit the RPM normally. So I'm going to go ahead and show you where to click first so I don't keep losing you guys. Over at these top icons, you see this little calculator. If you click on that, it'll bring up your math channels. You can also press Control M, love hotkeys, and it'll bring up a whole bunch of math. One of the changes I made from the previous version, or our previous project, is I organized our math channels per system. Previously, there's just one file that contained all these channels, as you see as I click between them. If you have that all in one set, it becomes a huge mess to work with. So in this case, we're looking for overrev. I know where it's generated, but a good way, an easy way to look at it is, well, overrev is related to the engine. It's probably going to be in the engine tab. Sure enough, it is. So to look at how the channel is being generated, you can double click on the channel or click on it, then click on edit if you want to, and it will bring up this nice math page. So you can see several features such as the quantity and the units that the channel is going to display as and what your math units are a result of. So when you're doing math, you always want to make sure that your result unit is correct to what your math is. Then your display unit would be just a simple conversion, which you can do at any time. As well as the color, number of decimal places, which that could just be 0, and then your actual math. So here's where your expression for your math channels are. You see operators down here, simple addition, subtraction, and or operators. Down here you see every single channel that's generated, and you use these channels to generate your math. So it's like if I clicked on fan PWM aux, it adds the channel. And because I just added some random channel and the math's not correct, channel values displays red. It says incomplete expression. It's not going to allow it to work. You also have additional functions, which there's plenty of them. I'll go over one or two that are commonly used. And then constants, which I generated. If I click out of this real quick, you see I have constants down here. Again, for constants, you also have a unit to display as. So if I right click on constant, I give it a name, a value, and a unit. So going back to overrev, to explain how this channel was generated, I'm using the choose function, which you went to functions, you'd find choose. And it comes with a nice description on how it works. So choose. You have the condition, comma, true part, comma, false part. And as it says here, it returns the true part if the condition is true, otherwise it's false. So then we'll go and look and see what we're doing with the math. Here we see engine RPM greater than RPM limit. RPM limit is a constant. The way I know that is it's not bold and it's blue. And you can also see in the constant over here, it's right there. So if that condition is true, what it will do is it will return engine RPM. Otherwise, it's going to return 1 divided by 0. So the important thing to know about 1 divided by 0 is in terms of I2, if you want to display that, it doesn't display any data because you're not going to divide any number by 0. Otherwise, if I just had it at 0, whenever the channel is false, I'd see this line of 0. So I'll go ahead and quickly show the difference between that. But to actually display this over rev channel, I need to decrease the RPM limit. So I'll go ahead quickly, go to RPM limit, and I'll set it to 12,000 because I know we've exceeded that. So it generates. I now see that there are values where over rev comes up. And what's neat about this right now is anytime you see an over rev, as long as you have over rev clicked before engine RPM, you'll see that it displays exactly over your engine RPM. So it's a good way to point out just visually with the color that your engine was over revving here. And as you can see, otherwise, it says NA. There's no data. That's because of the 1 divided by 0. Now, if I just change that to 0, you see this. You see your 0 value when nothing's active, and then the increase from when it's 0 to active. So in our case, I don't care when it's 0. I don't need that displayed because otherwise it's displaying no data. Engines below max operating range. And then I've done some additional things with this, such as an over rev counter and number of occurrences displayed in this channel down here. So you can see they may document it. I know in Optimum G it's in there, which probably how Neil found out, and then the rest of us find out. So I have a counter for the number of over rev occurrences that happen, as well as something to display when an over rev happens. So you see each time there is a yellow spike, that's when there is an over rev. So that's just going from 0 to 1, an on-off channel. Then I also have a counter that counts the number of times that occurrence happens, which is some weird math that I'm not going to be able to explain. But as you can see, it's like I just have this graph going from 0 to 1 because in this case, all I'm concerned about is this maximum value over here. How many times did he over rev? I don't need to see from 0 to perhaps 20, where this 0 to 1 value may no longer be seen. It's just, why was the driver over revving 11 times? In this case, it's a specific lap. So again, you can go and check out the math. The over rev counter is using some odd math to calculate the rising edge of that over rev occurrence signal. I really can't explain the math. And I also have it currently set up to each time, as part of the integrate function, this channel resets to 0 each time there's a new lap. So that's something to play around with the math. Well, not play around with, but go through the math and see how it's being used, how it's being generated. Because there's a lot of this going on elsewhere, and it's very useful to know like when we're using it and why we'd be using it like that. Here's a histogram. Here's another graph that's nice and useful. It's a rainbow track. So this specific graph is a rainbow track for brake temperature. what this does is it's using the GPS track that we generate, and it displays a color channel on that track of what the brake temperature is, or whatever channel you may want it to be. So it's a nice thing to in this case see like where we're getting higher brake temperatures. I also set up one for engine fogging. So I created a channel here to find out when the driver is below the optimum RPM range and when he's below where our engine really loses power. So here I have several different graphs going on. I have a channel report to show me, it's like, for example, in each lap, how long was he in our fogging, which you can quickly look and see what the math is. If he ever over revved, exceeding our driving range. And then I have my GPS track to see where it's happening. So I can do lap comparisons to see, was it happening consistently in a specific corner? Is our car not geared for that corner right? Was the driver not taking the corner right? So that's one way to use it. And on the topic of lap comparison, a way to compare laps is you have a data window over here on the left, and if you simply actually scroll over it, it will display all of the logs you have open and all of the laps. So to do a lap comparison, you're going to pick whatever laps you want, and you can see how you have this red circle on this lap over here. And if I wanted to compare against, say, this lap, or lap 15, I'd click on the square box. And now you can see it bring up another set of data. And I can continue expanding this by going to the third box and clicking another one. Sometimes, say in this rainbow track, you see it didn't add another graph because you're just starting to add too many graphs. There's some limitations sometimes. But you can compare as many laps as you want by clicking these channels. And if you no longer want to look at the channel, then just click it again and it goes away. Then when you're looking at a time distance graph, you'll see here that we have multiple traces being displayed. The primary channel is displayed as color. You can also press J. Is it J? Yeah. J will display all the primary channel values as just a single color red. I hate that function. But it's useful sometimes for some people. Otherwise, it's displaying the normal channel value. Then your secondary lap is displayed as white traces. Your third lap is displayed in this case as green. And up at the top, you can see what each lap is, what log it's from, and what the color is. I'm going to go ahead and get rid of this third lap, so I have too many channels. So looking at this lap, so I'm on lap 11 of the primary channel, and then lap 15 of the other one. I'm actually going to go ahead and find a lap of similar lap time. So I'm actually going to change both laps. Okay, now I'm displaying two laps with similar lap times, but there's actually a huge difference in what you see going on with, say, the RPM traces and probably other channels. He may have been quicker in some areas than others. And if your data is ever offset, say a beacon point for when the lap starts is missed, if you press O, that's your overlay. It brings up two more x-axis channels, which you can click and drag, and it'll move the graph over. It's a time offset. And over on the left-hand side, it tells you how much it's offset by. If you click O again, it resets, which I want reset. So then another very useful hotkey, so I remember it, Give me 1 second. Okay, yeah. F3 brings up a variance channel. And if you need to know what the hotkeys are, go to help topics and search for hotkeys or keys. You'll find it keyboard shortcuts. You'll find out what they all are in here. So this variance channel, very useful in driver and lap comparison. What this is it takes the timestamps of when the car started and the difference in their lap time. So again, time distance graph, whether you're in time distance, it's going to drastically change. Usually when I'm using the variance channel, I like to be in distance because you get a direct comparison of where each car was on that same lap and how far off they are. So looking at this, you can see for a good amount of time, one lap was actually quicker than the other. Then all of a sudden, you see this increase of nearly a 2-second gap in perhaps just a few corners. But then the other lap, he started improving his times and brought the overall lap time down. So using this feature is a good way to improve your driver because he was doing better on one lap than did worse. So you want to work those 2 laps together and tell your drivers like how you can improve. Sometimes it may just be your driving line where, say you're going into a corner really fast. One case the driver brakes before the other, so that other driver in your distance variance is going to get ahead because he didn't brake, but he may have waited way too long to brake and then loses time going into the corner because he overshoots the corner. So it's not always just because you see a decrease in variance that it was beneficial. Driving line, you'll see a lot of increase and decrease. So sometimes you'll sacrifice mid corner speed or entry corner speed for exit corner speed. If you're going onto a long straight, you definitely want to make sure you exit the corner fast because if you exit a corner 10 miles an hour faster, that time you spend at high speeds will more than likely benefit for the time loss going into the corner. And if you're ever confused of where the driver is on the track, if you press T, it brings up a GPS track map. You can see the little red dot, which is where the car is. You can click on it, drag him around too fast, and you can also get rid of that. And then there's also a track editor. Every time the car comes in, we generate the GPS track, which the GPS track is generated typically from the fastest lap. So you can see here it's categorized. I2 automatically does where the straights is. You can manually do it, but all it did was takes the GPS data. We're going to generate track. You can also generate a lap track from lateral G and speed. It's an alternative to when you don't have GPS. Each has their benefits because sometimes GPS will, the data will sway off. So you'll see sometimes like, oh, why is the driver, looks like he's driving off the track. If you display your GPS on Google Images, that's just from inaccuracies in GPS. No? So here you define what type of graph this is, or what type of trace it is. You can see how there's drive line, inner line, outer line. Sometimes teams will have their drivers drive on the outside line or inside line for one lap to generate, this is the boundary of the track, and they use that to compare what the driver's drive line actually is. You also select your lap for what lap you want to generate. In this case, it's closed circuits. Curvature is something I just play around with. Click OK, and it generates. And you can also rotate your model to fit the screen better. You can also, there's a lap editor as well to generate lap times. You can do it purely off of distance. You can manually insert beacons or using a GPS point, which in the case of the endurance event, we sort of just randomly picked a GPS point where the start finish line roughly was a comp. But since we didn't have the exact start finish line, it was just we brought the cursor over to on the track map where it roughly was, then use those values. And then it generates all our checks for us. And as you can see, there's no check mark on lap 13 because that's our that's when we went into the pits. That means it's an untrusted lap, so some channels will not display the data from that because the time where we spent at 0 RPM may ruin the histogram we're looking at because it'll just display a lot of data low RPM, and then the percentage RPM at other values is now lower. So I went ahead and made sure that lap is not trusted. There's also other ways to go about untrusting laps. Say the lap is too short, you can untrust laps based off a certain percentage of time because for all you know, it may just gotten a random beacon hit. If the track got too close to the start finish line and the GPS just picked up like, oh, I ran across the start finish line. When in reality, it could have just been a crossover track. It's also important to know where you're picking your GPS points. So you can export your data into Excel and MATLAB as well. If you go to File, Export Data, CSV or MATLAB file, that's very beneficial to some people doing scripts with MATLAB or Excel, obviously. Print screening your data. One common misconception that people have is they just do a normal print screen and then just take out what they see in this window that they don't need. But if you go File, Print to Clipboard, you have an option to do it as high resolution or low resolution. I always do it as high and have it as a standard feature. You print to clipboard, paste it into Photoshop or Paint, and it gets rid of the useless Windows data that would otherwise be there. It also displays it on a white background because this will typically be printed out onto paper where you're not going to want to waste a lot of ink. Yes?
You can change the copy paste parameters to do the MoTeC black thing. Right now, when you copy paste this white, for some reason I want to black, I can switch back and make it black.
Maybe. I'm not sure because I've never run into the situation where I wanted to print out in black. But more than likely you would be able to. A few other cool features. There's a play button. I'm actually going to go to our so-called virtual dash, where here you see a whole bunch of gauges. So the virtual dash is just a way to see it's like what exactly was going on with the steering wheel, your RPM gauges. I'm only going to display one lap here. And you can play and you see basically live time data of what the driver was actually doing as opposed to just these traces. So it's fairly neat. It's not too big of a use from it, but it's fun to look at if you are trying to figure out what a driver was doing. And then stop. It's at the top of the screen. You can also press A for start animation. It's one hotkey I don't remember. So yeah, go through all of these, see what we're doing with the data. You'll see every now and then, like right here, gear shift force, there's no data, there's no color. that's because it's a channel that was previously generated but was not currently being logged. Don't delete those because sometimes they are useful. Like gear shift force is just something we didn't have on the car, but it's going to go back on the car. So a lot of what you have to do is really play around with it, see what it has, like what the capabilities are, um, such as like corrected speed GPS, how we're generating those. I have an alias editor right now because channel names from previous years were different than what I had last year. I'm using this channel alias editor to say my any channel that comes in saying ground speed left displayed as wheel speed front left. That's something a lot of people missed and had a hard time comparing data between years, but it's now available to everyone. So that's the basics on how to use I2, and a quick note on actual data logging. So here's another thing about I2. If you right click on the channel, you can see it'll display how fast your channel is being logged. You can hide the channel, filter it, which I'll describe soon, offset it, or zero at cursor. So sometimes we forget to zero our damper position before going to the track. We can notice that right away in the logs. So we'll just, which actually I think happened here. So damper position. I'm gonna go to F2, and lap 13, where it stands still. So right now the car is doing nothing. And I can see that also by the G-force. G-force, both channels are 0. Nothing's going on, but damper positions are weird values because we didn't zero them. We forgot. So if you right click, zero at cursor, apply OK, it will do that. So if we ever forget, that's the way to correct our mistake. And this spike you see right here was the car turning off, and sensors just sending out a random value from voltage changing. Okay, so you know how to view the data, but you also need to know like what you're viewing sometimes. Sometimes people don't know how data is generated. A good example that happened over the summer was this air temperature inlet channel. Someone mistakenly thought that channel was related directly to the cooling system. As you can see, when I go to the cooling tab in the engine workbook, that channel is in here. So they thought that was the inlet air temperature into the radiator, which it could roughly be, but where is it actually being generated? Where is the sensor? I know where the sensor is, but I'll show you how you can figure it out. In this case, you'll need our data logging program, so everyone will just have to look at my screen. If you go to Tools, View Device Config, it will pull up your config for whatever device this was logged from, which could be the ECU or could just be our dash display. So I want to find out where air temperature inlet's coming from. So there's a view configuration summary channel. If I click on that, it displays all the channels that are in this and where they're coming from. So I'm going to look for air temp inlet. And it tells me what it's being used by and where it came from. So it's only being used to log, and it's coming from communications CAN, and it gives me the address. So it's like, okay, what's connected to communications CAN? But you're going to find all these sensors coming from this input drop-down menu. Communications, and it's on CAN channel 1, which is coming from the ECU. So from that, if you had the ECU file or a layout of the harness, you'd be able to see that that air temperature sensor is actually connected to the manifold, the intake manifold. So while it is measuring the air temperature, it's not necessarily the ambient air temperature that you'll be reading in front of the radiator. So it was a little bit of a mistake. Um, and specifically the mistake that happened, hopefully I can quickly find the log, if I still have it. I don't remember where I saved that log specifically, but what I ended up seeing was someone made an assumption that in this run, when the car went out, the air inlet temperature was really high, where in another run it was a little lower, and they related that directly to cooling effects, but they were very mistaken. From being several states away, just from looking at the data and knowing where the sensor was, I was able to determine the car was sitting out in the sun, the manifold was heat soaked, and the air inlet temperature sensor was reading high and not exactly the number that was at the radiator. So there's a little bit of a poor analysis on that just due to not knowing where the sensor was located. And that's something very important. Because if you don't know where your sensor is and what it's doing, then you're just looking at a bunch of dots and lines that are nice and colorful.
Yeah. You like the configuration summary?
Yeah.
Yeah, so you have functions that you generate from the function tab. Is that data generated on the fly on the while you're driving?
Yes.
So if you have too many functions, it's going to kind of box it down, like so under ADL.
It can. I have never seen any MoTeC products, or at least current MoTeC products, that were process limited. There is an option for us to log CPU usage, but because I've always seen it so low, I don't need to.
And also, the channels that you generate here is automatically, I would say, bundled into the I2 data file, but you make a difference we define it in I2.
No, it is. So, for example, functions. Let's go to calculations rather. Speed and distance. Um, right here, we're taking in wheel speed data from communications network with the ABS unit, and I'm generating a channel called ground speed. So that work was done here, and then it was set up in this logging setup to just define what rate it's being logged at and any filtering. So all that's done here. I2 is good at recognizing stuff like the GPS data. When it's in the setup, it's able to recognize quickly like what all the GPS data is because it's like GPS longitudinal, GPS or GPS lat. But this configuration isn't changed much, but it's useful to see where things are coming from and what we're doing. We actually aren't using the ADO very much, but it's like if you wanted to say do PID control with wings, our ADL is capable of doing that. So that's another important thing knowing is what our electronics are capable of doing. Because a lot of people don't know that the ADL can do PID control, which is just a control method to reach a target value. And you can use that for many things, which currently we're not using it because the PID stuff we use is all in the ECU currently.
So hypothetically, you use that for like clutch control.
What? Yeah, we could use it for clutch control. Fortunately, the ECU has clutch control function built in, so we'd likely use that. And then setup displays, alarms. There's also function to monitor channels and do a simulation. You can only do that when you're connected to the ADL with it on. That's just a simple shop test to see, it's like making sure everything's working. You can zero your sensors like steering position. We do that every time before we go out. And another thing I want to mention before I forget, something I added recently, is the logging setup in here has always been just like engine RPM greater than 400, less than 400, something like that. Just when the engine's off, stop logging. Um, so sometimes when people are trying to get logs in the shop, they have to change that logging setup and may forget. Then they change it to just turn on when the ADL is on and forget to change it. It's just going to be filling up the memory and wasting space, which we can clear manually, but it's still annoying when we pull a log out at the track and it's filled up with 20 minutes of data of the car doing nothing. And if we ever reach maximum logging capacity, it just deletes the first bits of data so the last stuff can come in. Because if your car broke down, it happened towards the end of your data set, so they want to make sure you can get your end data set. So what I did was, since I can't be connected to the ADL, I just print screened. I added a logging enable switch. So if you go to monitor channels or simulate, you can add this switch into your view and click it. When this turns red, it shows that your logging started. So that's a way to, without changing the config, just click it. I'm logging data, making sure all my suspension pods are in full range, that a sensor is working properly, and not changing my configs, because it annoys me when stuff is changed too much. Yes?
I remember one time I connected my laptop to the car, and I started trying to open it up on the sensor, but I overrated with following, if you remember,
Yeah,
last summer. Is there a way to not to screw that up?
that's purely user error. So, so if you're gonna send a new config, make sure you, one, always download the config that's in it, which it does a pretty good job at doing that itself. But do that so you have a backup. Put the file name you want in. But our logs always have, as shown with the log, it always has the um, ADL logs with it. It just loses the file name, but that's no big concern. So it's something that can always be changed. So that was fairly simple. Now I'm going to talk real quick about filtering and logging rates. So the data I'm about to show was logged from an ACL6, which is a device that we do not have, and it was capable of logging channels at 5,000 hertz. Our ADL is only capable of logging at 1,000. But I was using this as an example of some high frequency generated channels to show the importance of logging rates. So it was I had a set of samples going at 20 hertz, and then I'll show you a set of samples at 200 hertz. So here's a 20 hertz, roughly 20 hertz sine wave being generated at various sample rates. So I see I have one at 5,000, 1,000, 500, 200, 150. And each of them are a different color, very useful in comparing something like this. So you can see right away, this purple channel logging at 50 hertz, it's not displaying anything close to what the actual function generator was doing. That's because if we go and look at the individual data samples, we just got one data point there, one there, and so forth. And the reason why I was just getting those is it was doing an average of the channel voltage between those two timestamps. And because it wasn't sampling at a high enough frequency, it's displaying bad data. Some people like to say there's no such thing as bad data, which The only useful thing this shows me is it wasn't logging fast enough. You can see this orange sample. Okay, a little off. Depending on what you need, that may be okay. Sometimes
What frequency is the orange?
everything's at 200 or 20.
Okay, what frequency is the orange?
Oh, logging frequency 100.
Whatever.
Yeah. So let's just say you weren't looking for super precise peaks. You were just looking for the general waveform. Then 100 hertz in this case may be good for you, and it may not be necessary to log at 5,000. The higher your logging rate, the larger your file will be, the longer it will take to download, more space in your computer. So I'm going to hide some of these lower channel values because they're not doing much good. Now you can see between 500,000 and 5,000, they're displaying roughly the same data. I have to really zoom in to see differences here. So you can see the faster logging rate is getting the data sample just a little bit sooner. If I can do a quick comparison of what it was. So
red was 200 hertz?
Yeah. So I have my cursor right here. I'm going to use the datum feature. If I press space, it sets a datum point. And what this is used to do is compare values between the datum I made and where my cursor is. So I put a datum on 2.8. Now I'm going to bring the, let's just do the yellow graph to 2.8 as well. So that's the difference between them, which, depending on how far you're zoomed in, would look like a lot. But on the bottom, we see the delta time was 1,000ths of a second. That's usually not a concern for us. 1,000 of a second is very minuscule, even with something like suspension pods. So even 500 hertz is displaying some pretty good data showing what the entire waveform looks like, and is logging 10 times less samples. But then, if we go to a higher frequency, 200 hertz, all of a sudden we see that 500 hertz logging channel is no longer providing sufficient logging to show the exact waveform. And even in this case, if I look at the peak for the 5,000 hertz channel, I may be missing the precise peak. May be concerned, may not, depends on what your needs are. So that's the importance of knowing what your logging rates are. And then I also have examples of a square wave. Some limitations here are due to the function generator itself. So you can see here, oops. Even still in this case, 200 hertz at logging rate 50 hertz, it's not displaying what I want at all. Now, a real quick note on filtering. Filtering does an averaging of samples to smooth it out. That's the simple definition of filtering. But you need to be careful with what you're filtering. Some stuff needs a filter, some stuff doesn't. Sometimes it will. So it's like, it's not just what the channel is, it's what your use is. So sometimes I'll filter out the battery voltage channel I talked about before. So I'll show real quick. So I can go ahead and filter this out, and I'll lose a lot of those small peaks that happen due to the ABS unit. So that's something I do to see the real voltage decreases. So going back to this function generator, let's just say I'm taking this yellow channel and increase the filter. You can see a small change. Not bad, but if you get too high, all of a sudden your peaks drop. You may have a shift in the graph just because you filtered too many samples, because what it's doing is taking, in this case, 15 samples together and taking the average of those to smooth it out. You can also do it by time. And one thing to be careful of is filtering with even numbers. So I'm going to have to zoom in for this. I'm going to go ahead and filter this blue channel. And if I filter it by 2, I see a phase shift. And it shifted it nearly to pretty much the exact same thing as the yellow channel. So I'm logging it twice as fast and just filtered it to something twice as slow. That was a fairly useless use of the filter. So you need to be careful on what your filter value is. There are recommendations on what you should filter and by roughly how much, but sometimes it's really just playing with it, and it's like I smooth the data out to how I want it. Yeah, if you want to save a filter, one way to do it is if you go to the maths channel, click on whatever thing you want, you can put a filter in. There's several different types of filters, so you can always filter a channel. So there are some suspension parameters in here that are, yeah. Yes. Well, we use their functions for filtering, and you can put in your own parameters. Yeah. So this program is extremely powerful. I just barely touched what it actually is. You'll see teams using these programs to calculate center of pressures with wings when they're driving based off of, say, wheel force data and suspension position, something unique that I saw. And they'll generate it in here to see what the effects of the center of pressure or where the center of pressure of the wing is with each change. And they use these logs to keep track of where they are. And you have all of these math channels you can do. It's a very user-friendly program with obviously a lot of features, and you're pretty much limitless with what you can do. I can add to this time distance graph really as many channels as I want. You won't always want to have every single channel in as you can, but just clicking a lot of channels, they'll all go in, and you can even do more. So that's the purpose of having the worksheets, to avoid having a clutter of all these channels. Yep.
So when I was at the Optimum G seminar, Father Raul, who's a risk engineer, with F1 in the any kind of institution.
No. Speak towards the computer, I guess.
Oh, yeah. So at the Optimum G seminar, Father Raul, he's a race car engineer. He's done almost every single racing series you could imagine. So he said he got his company to actually use MoTeC's i2 Pro, and let's say somebody hires them for the day, and the driver goes out on the track, and they do 10 stints on the track. And what they would do is they have a program that basically runs with i2, and they just print out a report, and it automatically says, all right, you're braking too hard here, your downshifts are too, basically it's a report for how good or how bad you're driving. So if you know what you're doing with this program, it can be extremely powerful in general, which blew my mind away.
Yeah. MoTeC is a very well-known company in the racing industry. Their products are a little expensive, but we're getting what we pay for. Not everyone has the um, money to buy this, so we decided like it was definitely a good use to get us this functionality with what we have because this program is free to download. The little bit of extra money we paid was just for the device, and now anyone is able to view this data. On the topic of that, under no circumstance should you give anyone else our data. Our data is how we're tuning the car, how it's performing. If we could get a hold of other teams' data, I would love to, because we could make our car better. And I know they don't want us to have their data. Also, they get our configuration for the data logger to see what we're doing with it, which if we're doing any trick math features in there, they'd see how that's being performed. So this should not be sent out to anyone.
Do you have any recommended books for data?
Oh, yes. So recommended books on data. And also sorry for going a little over. I didn't do a run through before, so 30 minutes over. Recommended books on data. One book I recommend everyone to read is Making Sense of Squiggly Lines. It's an introductory data book by Chris Brown, who is a MoTeC engineer. It goes over some simple channel analysis, like RPM, driving, braking. It's something I want everyone on the team to read. The team will be purchasing a copy soon. We forgot. So that will be come in within the next few weeks. There are some other books such as Race Car Data Analysis Techniques. I believe that's the name of it. But it's a more advanced book. But if you're getting along the way of getting more involved with data and data analysis, then you'll quickly be able to find the data books. There's not too many out there, so I've just pretty much done go on Amazon, read reviews. Not many, several are garbage. But Chris Brown's book is by far the best introductory data book I read. Any questions? Nope. Well, that's all. If you guys need any help with anything, consult me. There's other members on the team that are proficient with this program, such as Jonathan, George, Neil, who's currently at SpaceX. Just ask around and we'll be able to help you.